Okay, everyone, welcome. So, this talk for today is reserved for the silver partners of this year's conference, Comtrade System Integration, who have significantly contributed to achieving everything we envisioned here. And now we will have Boris Cergol, Head of AI at Comtrade System Integration. Boris will be presenting DSPy, the end of prompt engineering as we know it. In this session, Boris will introduce DSPy and a groundbreaking framework that automates prompt optimization for large language models. By replacing manual prompt engineering with a modular and declarative programming approach, DSPy enables developers to define desired outcomes while the framework automatically optimizes prompts and performance. Give a warm welcome to Boris, please.
Hi everyone. To start this talk, I will speak first a bit about the so-called dark arts of AI. So I believe that, I guess everyone in the room who has been in this business for a while or is maybe as old as me or older has seen, these cycles of technology that have happened and have passed us. And, for me as well, there was a period where I was really focusing on machine learning over structured data and predictive analytics. Then there was a period that I was focusing on deep learning algorithms and computer vision. And then, of course, onwards to large language models and generative AI. And one thing that I noticed is each of these paradigms always has this, what I in this talk called dark arts component, right? So this is something where, only certain people have the gift to do it. It's hard, it's iterative, it's, undeterminable. And, for machine learning paradigm, it was feature engineering. Then deep learning came and we were constantly worried what kind of architecture to create that is optimal, that is able to train fast enough and well enough. And I think now with generative AI, probably there are a few different things, but for sure one of those is prompt engineering. So maybe also kind of a quick comment. How do you know that you are involved with the dark arts? Well, for starters, probably you notice that the role that you hold in the company totally does not reflect what you are doing. Another thing is, if the role that you do has been named, then you will notice that in the media it is called job of the future. Also, maybe with adjectives like sexy or trendy or hype or stuff like that. But, of course, as always with these kinds of things, systematization does happen, right? And with feature engineering, a lot of that has been automated by AutoML for different kinds of problems. It was, simply deep learning happened and we didn't need so much feature engineering anymore. I'm not saying feature engineering is gone, right? But it's no longer so much the art that it used to be. And interestingly enough, also what happened then with this architectural designs. So actually here it was a bit different because we got so much more new compute that we simply could use some standard architectures. We didn't require to be creative anymore, plus of course the pre-trained models. And the question now is what will happen with prompt engineering? How will it be systematized and when will this happen? And maybe bonus question is also what follows, which is the next of this dark arts that we'll be concerned about. So maybe a few words about the pain points related to working with prompts and prompt engineering. So as it happens, this process can be quite inefficient in the sense of development. There's lots of this trial and error tweaking involved. Often, there's no clear systematic way. How can you improve, let's say, a certain prompt? And still often it relies on a certain sense of, let's say, individuals, to make the next step. Also, when you have worked on a prompt for quite a while and you are happy it's working really great, it really can be very brittle, and brittle in different ways. So one way is that it might be really tied to a certain use case or business case. You cannot apply it to something else. Also, and this is even more problematic, it can be really closely, adjusted for a particular model. So when the new model comes along, you're kind of scared of even implementing the new one. And now models are coming all the time, every week. So it's a constant problem. Not to mention, that you have these examples. You have a prompt, you change one word, and something unexpected happens. Or maybe you didn't even change the word. Maybe you just changed the word order in the prompt, and it's different. And also, it's hard to create some sort of continuous improvement, right? So you have a static prompt, data is coming in. So, but what do you do? I mean, do you what? Manually edit the prompt? There is no automatism. And here more as a joke, of course, those of you who've been working on this know this very well, right? You have some prompt, then next week, maybe there's something, you notice something's not working so well, you add a bit to it, and then you discover some edge cases, and you add again, and then, of course, new model comes, and you have to start over, right? So, about DSPy, what is this? It's an open source programming, and the value proposition is basically that it's for programming LLMs rather than prompting them. Core idea is, instead of trying to write the prompt to get this ideal behavior from the LLM, you just basically define what you want, and then you also choose some metric how to measure whether it's working well or not. And then it's up to the framework to help you out and make that happen, right? So DSPy, it stands for this declarative self-improving Python, quite a mouthful. So declarative is this thing that you basically define what you would like to get. This is a bit of a strange framework, because I notice people, when they see it, they say that it's complicated, that that it has strange abstractions. So I decided to really go over them, because there are not so many, and I don't think it's so bad, So first of all, we have something that's a signature. It's rather similar to signatures in regular programming. So this really just defines what are the inputs that will go into the the task, and what do we want as the output. Then we have modules. So modules are these reusable components that take care of like small subtasks, let's say. And here I have some examples. If a model has to call some tool, that can be like a module. If it has to just generate some prediction with an LLM, again, this is a module, right? So then we have assertions. Assertions are just constraints, or let's say preferences. There are two variants that we require for the modules. And so one example, very clear, would be if we, let's say, if we want to do a classification, and this is, one module, we might require that only, that only 10 values that are supposed to be, that we are supposed to classify are allowed as the output. That's a trivial example. So what we call the program. So program is just a list of all of these modules in the pipeline. Metrics. So metrics are really, this is how we define what does it mean that the task is going well, that it's successful, that, how to measure success. And examples. Examples are input-output pairs that we might somehow have, either from some previous data set, or we might accumulate them as we are running this pipeline. And the last thing is really the one that's most interesting, I would say, are the optimizers. So what the optimizers do, They try to automatically tune the prompt. They can also, in some cases, tune the weights of the model that is being used. And also they can select from the examples a subset, and they include that into the prompt. So they do this few-shot learning. So maybe let's see it on the picture. In one example of a RAG system, how does this all come together, right? So here we have a question from the user. So signature in this case of RAG is basically on the input side, we have some context and the question from the user, and then we want to have the answer. So this is literally the signature. So for the context, we retrieve from the knowledge base, and this is one module. And then we have, I mean, it's really hard to read, right? It's chain of thought. So various kinds of prompting techniques can be considered modules in this framework. And finally, we have the LLM. In this case, I guess is Mistral that generates the answer, right? So this here, everything together, this is what's then called the DSPy sorry, program. Oh, I have the laser, right? It's great. And then we have some of the additional components. So one is the, as mentioned, examples, or here they call it the train set. And also here are matrices. They can be, some of them are, can be rather familiar, like things like accuracy, but we can get very creative with them as well. And then we go to the optimizer. So here, the previous program, the unoptimized one, and the training set, and the matrices come together, and the result of this optimization is basically an optimized program that we can save or run or do whatever we want, right, with it. So maybe when it comes to these optimizers, which I mentioned are kind of the most interesting part, there are three groups of them. So basically the first one, the most, let's say, basic one, is automatic few-shot learning. So here you can imagine that you have a list of examples, right? And with this optimizer, you can select a few of them and include them in the prompt, because including them in really improves the successfulness of the task. Then in the middle, we have this instruction optimization. So this is literally the optimizer is trying to change the prompt. So the performance of the task is better based on the given metric. And lastly, this automatic fine-tuning. I believe this one is kind of still in development. For the other options, there are different, let's say, instances of optimizers, but for this one, it's just one. But it's a useful one. So basically, imagine that you have a long chain of prompts, and finally, some big LLM and at the end of it, right? You might want to not use the large LLM. So what the system does, it trains a smaller model that is able maybe to do this exact task about, with similar accuracy. So it's really a distillation of that chain into then you just make a single call to this smaller model. So maybe if we look now at how does this look from the perspective of the code. Okay, so of course we import the DSPy library. So here we define which language model we will use. In this case, it's GPT-4o Mini. And yes, we should put in the API key. However, it's important to notice here that we could use any model here. And the nice property of this framework is that nothing changes, You just have to, you just change this initial definition and everything else stays the same. It's really rather model agnostic. Okay, so here we go now to search. And here, basically, we define a module that is using Colbert model on this document that is obtained from this URL. And it returns basically 3 most relevant pieces of text and returns this. Yeah, so now again, we do the chain of thought. So we combine basically we combine reg with some chain of thought. Here is the signature, yeah, so this is then how we call the DSPy program, right? So we put in a question. So for the question, we first do the search, you know, altogether then we get the generated answer. So this is just an example of how we define a DSPy program and how we run it. Now this next example is interesting from two reasons. So here is an example of a rather basic agent. So the classic React agent. So this is the agent, it gets a question and it has access to some tools and then can use the tools to get some clarifying information. Again, we choose one language model. Again, we have the retrieval. You know, the difference here is now that we call this React. So this is this agent. And here, so I don't fall. No. Yeah. So here for tools, right, this agent has access to only one tool, and this is the search tool. So basically, it can search the knowledge base for clarifying information. And here is literally where the optimization happens using this MyPro V2 algorithm. So this is the one from the second category. So it can actually change the prompt. However, this one is actually a combined algorithm. So it can change the prompt, but it can also enter some of the examples into the prompt. So it combines prompt adjustment, you know, with the changing the few-shot learning approach. So, you know, as you see, not a lot of things are to be done here, right? It's mostly important that you have the right train set. So here, in this example, this is where we generate the train set, right? So we take some well-known Q&A data set, and we take, in this case, we take 500 examples. However, in many cases, this can work quite well also with 20, let's say, or even 10. Or in some cases, people do it maybe even with just a handful. So, yeah, it's also not so expensive to run since, you know, the sample size is so small. Okay, so one big question now is this just a gimmick, or does it actually do something interesting, right? Here I found one example that I believe is quite interesting. And the example was about, so they took the Llama 2, the 70 billion parameter-sized model, and they evaluated it on some mathematical reasoning benchmark. They ran it through the DSPy optimization, and interestingly, this is the prompt that it came up with. So it invites the language model to role play that it is in the Star Trek universe, possibly because some logic that you know, people there are better at mathematics. So that was quite a weird result, actually. But you know, so a lot of stuff with LLMs is weird anyway. Okay, so this next example of usage is maybe a bit more serious, maybe even worrisome. So here the context was that you know, it was red teaming of another LLM. So basically, one LLM tries to go over the guardrails of another, and here basically the way it was done was that you had a kind of like this class of attack function. You know, so here, you know, you create an adversarial attack prompt that instructs another language model to produce harmful intent. So this function, this module tries to generate this harmful intent from the other model, and then there's another module that basically looks at what happened with this model and provides feedback, basically provides ideas to the next iteration what to do. And so here, you know, without doing this architecture and DSPy optimization, so the baseline was 10% success rate. With DSPy, it jumped to 44%. So I think, yes, in certain cases, it can already be quite useful, or, I don't know, possibly dangerous. Not really. And so just to recap a bit, why you might want to use this, right? So obviously the most obvious use case is to reduce time spent on manual prompt engineering. I said reduce, not remove, obviously, but since the optimizer can help you find like maybe a better prompt. Also, I think it's useful that this whole framework really puts the focus on how to define success well. So you think about it, how to evaluate whether we are getting from these models what we actually want to get from them. I think that these evaluations are really important, possibly when it comes to creating these systems. Maybe it's even the most important component right now. Then you have the benefit, as mentioned, of model independence, so you don't need to be so worried when a new model comes out that everything will break down if you use it. It also gets easy to test. You can do like a canary deployment, maybe on small scale, easier now, and see how it behaves. Plus, you can actually have continuous improvement, right? As you are getting new data, new examples. Maybe a good example, let's say that you have a code generation agent, right? And then you are constantly getting examples where the code that it created was successfully executed, and examples where it wasn't. And then you can pick from those that were successful and optimize the prompt in order to get them, and so on, right? Of course, I don't want to sound like a kind of salesman for DSPy. I'm not in any way affiliated with this project, just to be clear. So what are some of the criticisms? Okay, so I will start on the right-hand side. So this is how the stars on GitHub are rising. And as you notice, it's rising linearly, not exponentially, which has me worried that maybe nobody's using it. Also, people are saying that the learning curve is steep. I think it really depends from where you are coming from. I mean, for people who have gotten used to just, like manually writing some prompts, and maybe they never even have done any programming, yes, it is steep. But I believe that otherwise it's not such a big barrier. Unfortunately, documentation is rather inconsistent, and they are changing some names of even of these high-level abstractions, which isn't so nice. But I guess, on the other hand, it's still quite new. Also, there might be an argument made that they overcomplicated this a bit and that it could be simplified. Not sure about that. And the last one is interesting. I referred a bit to it in the beginning. So, okay, let's say that this really works how it should, and basically we don't have to be so concerned how we write the prompt. But then now we have to be concerned which metric we choose. And I think that in many cases this can be even harder, to think about exactly what should the metric measure, or maybe it shouldn't be just one. Maybe it's actually like an ensemble of 32 matrices. So, maybe this is the next dark art here right in front of us. Yeah, so with that, I'd like to thank you for your attention, and I welcome some questions.
Okay, do we have any questions for Boris?
Thank you for your presentation, very interesting. I was wondering if you could share some insights in how the prompts are actually optimized under the hood, because something similar I saw was context optimization for vision language models, which is basically gradient descent learning of the prompts. So if you could...
there's quite a bit of these optimizers, and everyone has a slightly different logic behind it. So I think it's really best, to dive deep into the algorithmic implementation. So, for the fine-tuning one, that one is rather obvious. What's happening is distillation, right? For the prompt one, I think it's some hill climbing algorithm. So it's doing something with that. But yeah, they're all different. There isn't like a single approach, and it's actually a very active area of development. You know, how to actually do this. What does it? You know, what approach to take in these optimizations?
Thank you.
Thanks a lot for the presentation. Yeah, very interesting framework. I've also come across it. Just wanted to ask you, like, what is your experience, let's say, for the real use cases? Would you recommend using it? And do you see a big benefit in, for example, time or some edge cases that can be solved with this approach? Because at the end, it's a black box. You need to understand in the background what's happening and how it can, yeah, your experience, like in real use cases or.
Yeah. So currently for us is still experimental. So we haven't been putting this into production, so looking from the perspective of where we have problems when we are implementing this, you know, simply if we have something that is able to help us just with the case where we have to integrate a new model and forget everything else, so just this, something like this would be extremely useful and I'm sure would save a lot of time. But like I mentioned at the end, currently maybe it's still a bit rough around the edges, but it is getting, you know, it's, you know, under very active development. So if something better does not come out, let's say in the next few months, I think this is something that I would recommend using.
Thank you very much.
Hello, thank you for a very good presentation. Do you have maybe experience how stable it is if you run it multiple times on the same language model? So does prompt stays the same or does it change? This is the first question. And the second one, if you could be more specific, the difference, let's say, between the GPT-4o and, let's say, Anthropic Claude, how much on the same data set would prompts differ between each other, if you have any experience with this?
Yeah, for the first question, I can tell you that, I mean, it's, you know, in the end, it's always some like Monte Carlo and multiple threads happening and so on. So it's stochastic. So there is no assurance that, you know, even mathematically, there might not be like an optimal prompt. Most likely, it's that space is weird, and you know, who knows what sort of local minima are there and so on. So you know, you cannot expect that you will get the same prompt. However, what you can expect is that when you select the metric, the performance of the pipeline should be roughly the same, right? So there shouldn't be like big discrepancies, and so then you can. You know, if you were able to define the metric correctly, so what does it matter if it's a bit of a different prompt? As long as it works how it should work, and you know, the metric that you so carefully chose and is the right one, then there's no problem. When it comes to so Anthropic and OpenAI models, so there is actually one example that was published where initially for the GPT-4 model, they run it through some DSPy optimizations, and it was, you know, quite a significant improvement on a particular task. So, but you know how those two compare, it's hard to say. I did not test them, you know, on a certain task, and possibly it's task dependent. So you know, you have to define the task and the metrics, and only then you would be able to run the test and see which one is better.
Hi. You mentioned that it's important to have a ground truth, so the same in case of some question answer, so some pair. In that case, I assume it would be good to kind of separate into some kind of training set and test set, just to avoid overfit. And is there some kind of optimal split?
Yeah, so that's a good question, and something I actually forgot to mention during the presentation. So it doesn't have to be ground truth as we are used to it. So actually the metrics that you're running could by itself be a DSPy program, right? So, you know, because in many of these cases you are using actually an LLM, or possibly LLM prompted through a certain pipeline in order to determine whether that other task is actually performing as you would want it or not. So here, however, if you have cases such as question answering or classifications or things like that, then for sure, yes, you would go with the basically training set of ground truth answers, right?
Thanks.
Okay, so thank you all. You can ask Boris any additional questions during a coffee break since you were also interested. Thank you.
Thank you.